Now in this video, I've got an integrated circuit. I've got a square wave on the input in series with a 10 millihenry inductor and a 200 ohm resistor. The square wave is on the input, and on the output I have a triangular wave. My square wave has a 5-volt peak, and the wave is also bounced around zero. Now I'm going to find the output voltage. The first thing that I need to find is my L over R time constant. And my time constant equals my inductor over my resistor. And so I've got 10 millihenries over 200 ohms. And that equals that equals 50 microseconds. Now I'm going to find my frequency based on my 50 microseconds. So on my input, my half cycle will be 50 microseconds. And I'm going to have 50 microseconds here. And that gives me a 50% duty cycle. So now I'm going to use these values and I'm going to find my frequency. $50 microseconds times 2. So my frequency equals 1 over 50 microseconds times 2 because I've got 50 microseconds here and 50 microseconds here. And that gives me a frequency of 10 kilohertz. All right. Now my voltage will be a peak-to-peak voltage on my output, and it's 1 over 50 microseconds integration five dt. Now I will be integrating this from 0 to 50 microseconds. And that equals 5t over 50 microseconds plus c. Now I plug in 50 microseconds where t goes, and I will get an output voltage of 5 volts peak to peak. V out 5 volts peak to peak. And since my signal will be balanced around 0, meaning that it spends the same amount of time above 0 as it does below 0, I have plus Vp equals 2.5 volts minus Vp minus Vp equals minus 2.5 volts. And this brings me to the end of the video. Subscribe, like, share. Subscribe, like, share. Thanks for your attention.